So, hello everybody. I believe we're live. So, my great pleasure to introduce Michael Scriney for So You Want to Be a Researcher.
Good. Hello, everybody. Yeah, so I'm Dr. Michael Scriney. Pleased to meet you all. And here is this presentation is essentially a very quick overview about what exactly does it mean to be a researcher. So what we're talking about is kind of like, how do you get to be a researcher? And then a bit about what is your day-to-day life. So we'll start with a bit about me. What was my career path? How did I get here? Then we'll talk in a bit more broader strokes about like, what is a researcher? On a very high level, what does that exactly mean? And then we'll talk a bit about what do you need to be a researcher? So what attributes do you have to have if you want to do research? We'll talk about how do you become a researcher? And we'll talk about why would you want to put yourself through that? And then how do you get started? And finally, some questions and answers. So who am I? Well, I'm an assistant professor in the School of Computing in DCU. I'm basically a programmer at heart. I have a BSc in computer applications and a PhD in data engineering, warehousing, and analysis. And my research interests are educational technologies and green technologies. And this will be important later. I am a lifelong learner. So what's my career so far? I'm pretty young, so I'll give you the broad strokes. I have a BSc in computer applications. I'm a graduate of the DCU computing course. From there, I went to work, came back, did a PhD in data engineering, data warehousing, and data analytics. After completing my PhD, I then became a postdoctoral researcher in the Science Foundation Ireland Research Centre Vista Milk. We'll talk a bit about that later on. And now I am an assistant professor. So, what is a researcher? Well, someone who carries out research. Very broad. What is that in essence? Well, for computers, it's trying out ideas. It's running experiments and it's disseminating your work. We use this term a lot, disseminating. What does that mean? Basically means getting the word out about your work. So the way you do this is through publishing papers, giving talks at conferences, or other maybe like industry events, and generally just anything, public engagement, social media, all of that is dissemination. So more specifically, what's a computing researcher? Again, we're still in very, very broad strokes, because even within the School of Computing, there are people who would work in computing research, but a wide array of disciplines. We have people who work in image recognition. We have people who work in natural language processing. We have people like me who work in data warehousing. We have people who work in just specifically things like software design and principles, human-computer interaction. The list just goes on and on and on. Okay, but what do you actually do, right? Generally, you're programming, right? You're programming systems, you're programming algorithms or something like that. So within your field, you'll get an idea of something you want to try out. Like maybe if it's image recognition, you get an idea of like a new algorithm, or you get an idea of like, oh, if I merge these two systems together, if I steal an idea from another science, I can program this and, get some kind of benefit out of it. So you come up with an idea. It could be a system, it could be an algorithm, and then it's on you to design and implement it. And then you test it a lot. And I know that for students, testing is a bad word. But the thing is, for us, when you get to the next step, which is writing up papers on your work, you're actually publishing this system to the wider world. To publish a paper, it is sent off to reviewers for basically people who work in your field to look at it and say if it's good or not. So you have a very high bar to reach in terms of the testing of your system to show that it works to the specifications that you've made and that your experiments make sense. So what kind of person do you have to be a researcher? Well, there's two really main traits that you have to have, and they can be learned. first one is you have to be inquisitive. It's actually in the name for a doctorate. A PhD stands for philosophy doctor in Latin. Philosophy comes from the Latin philosophy, which actually means the love of wisdom or knowledge. And then doctor comes from to teach or to be a scholar. So in essence, the idea is that you never stop learning anything. You're constantly reading and trying out new ideas. Every Friday, my workload is I read papers. I read the new papers that have come out in my field. You keep buying books. You keep reading blog posts. You never ever stop reading. So yeah, research papers, books, and blog posts. And this is doubly so for computers more than anything else, where the landscape just changes so fast. Like the meme is like, another day, another JavaScript framework. But that's true. You have to stay on top of this. Like if it was another field like history, for example, things don't change that much. No one's going to really discover, a new civilization these days. So the landscape doesn't change. But in computers, it can change week by week. So there's an imperative to stay on top of all of that research. So you are reading a lot. And what's the other trait that you need on top of being generally inquisitive in nature? Well, you have to be self-directed, right? In research, in this kind of job, you actually have very, very little oversight, right? There is no manager really who comes along and tells you, have you done X, Y, and Z? Did you do this? Did you do that? So everything is all on you. So if you come up with an idea, you have to have the drive to see it all the way through, to design that system and see it all the way through, which can be a problem for programmers, as I'm sure all of you have many half-filled GitHub repos of projects that you were like, oh, I'll get around to that someday. Unfortunately for research, you have to be able to sit down and see them all the way through to the end. But why do I like my job? Right? Why do I do this in the first place? In short, freedom. Freedom is why I like my job. When I worked, I have the ability to work on what I want. And this was a big one for me, because when I worked privately, what you found was you're kind of in a space where you have a manager, you probably have a client, and you're designing system to a spec. For me, it was a consultancy, so we're designing a lot of intranet systems. And I was looking down the road and thinking to myself, there's only so many intranet systems that I could design before I would get very, very bored of that. But even then, if you were broader strokes and you were a system architect or something like that, you're probably still inside a bit of a box. Whereas in research, you can just try out 100 different things in 100 different fields, and that's your job. So you get a lot of freedom to work on what you want. I get to constantly play with the new technologies that come out, which isn't something that you could do really inside a private industry. I couldn't turn around and say, I'm going to build the next system in Go and have everyone there who's experienced with Python say, okay, that's fine, go do it. So I get to always stay on top of things and play with the new toys. A really nice benefit of the job is you get to meet a lot of people. You get to meet very interesting people, talking to other academics or companies or government agencies. You always get to meet new people, especially other academics, because they're expert in things that you have no idea of, and it's learning about those things. So an example would be if I was working at the School of Chemistry, just learning all about how do cancer cells work. It's very interesting. The School of Physics, there's always room for us to teach each other. And then to be like really airy-fairy and sit on my ivory tower, you get to do work that matters. Harder than it seems, but yes, you can do work that actually matters and has a very human impact. You can do research to help people with Alzheimer's or to aid anyone with disabilities. You can do work that really, really matters and helps people. And that is also one reason why I like my job. So, very broad, I'm going to give you a quick run through of what kind of projects have I worked on when I say that you work with a lot of things and when you work with a lot of people in a lot of different spaces. So I work with the School of Sports Science, And what we're essentially doing there is trying to optimize the training processes for athletes, right? Optimize their goals and have this goal-based workout plan individualized for each athlete. I work on a fintech startup funded by Enterprise Ireland, where the goal of that is to do analysis of financial accounts. I'm on a few projects on educational technologies, one within the school and one with the language school, Salus, where we are just trying to optimize different ways of learning. So the educational technology ones actually involve us doing full stack engineering and building websites and playing around with HTML5 and different video codecs. Work on green technologies for another project. And what this one is essentially, it's what my PhD student is doing, where we have an industry partner and we're trying to perform a what if environmental analysis. So if someone comes along and says, we want to build a power plant in this area, what will the effect of that be? So a lot of simulation, a lot of working with real data, working with people from the DCU Water Institute and the School of Geography and bringing in all these interdisciplinary teams. Previously, I've done some work on biomedical devices, where a startup was releasing a biomedical device and they asked, hey, can you do some analysis to tell us if we're on the right track with the data we're getting out of this? And then in Vista Milk, I was working on data in agriculture, trying to figure out greener ways of doing of farming and food processing. And then most recently, we're working on actual COVID data from the government, where we've been asked to basically help and try and find more in-depth analytics. So a lot of projects, and no person is an island. So for each one of these projects, there is a team. Every single project that you do will always be part of a team. And we like interdisciplinary teams where you and other members, you all lend your expertise. So a great example is I'm a programmer at heart. I control systems. I can do full stack engineering. I am not a designer. I do not have an artistic bone in my body, but there's someone on the team that specializes in human computer interaction. Perfect. We'll work great together. And so you'll have teams of people who work in sometimes wildly different areas. So a programmer and someone from the School of Geography, where you have to find a common ground, you have to try and understand each other, come up with a way of speaking to each other. But you will have a role in each team, right? So, example, you could be the machine learning person. You're the person that gets the data and does the machine learning. You're the governance person or something like that. Or for some teams, when we get through the career framework, it could actually seem a bit more like this, where there's a tiered level of expertise going down from the professor all the way to an undergraduate student who's working as a summer RA. But what's our development process? We were Agile. We were Agile before Agile was a thing. And the reason why is that the projects evolve rapidly. They evolve very, very quickly. And usually in each project, there's a common word in startups, but you'll pivot, right? So you'll just have to change the direction of your approach. You'll have to change your research idea. And there's loads of reasons for this. Sometimes it's just your idea mightn't pan out. Your hypothesis was incorrect, and you're just trying to salvage the amount of time that you spent building the system. Sometimes, more often than not, we find that it's actually maybe the data's bad. There was an incorrect assumption made about what data we were using. Or sometimes it's that you thought of something more interesting. Like one example of a project that we're currently pivoting is we were trying to look at kind of like students attending lectures and tracking their attention over time and all of this stuff. And then what we found out is pretty much students don't attend lectures or don't pay attention when they're there. So we didn't have very good data for that. So we pivoted to say, okay, but how do students interact with the lecture material if I posted a video up online instead? So naturally, shift your focus, start programming up new algorithms, putting these little things added onto your system, and pivot in that direction. And you will pivot a lot. The level of management on a project is roughly equal to the level of funding that you get for that project. So if it's little or no funding, kind of just a bit passion projects that you'd have with other researchers, that very much turns into like emails, Zoom meetings here and there. Work on it when you can. For bigger projects, you could even have like a dedicated project manager who's a salaried employee, whose job it is just to manage that. You'll have Jira, you'll have your Gantt charts, you'll have your daily stand-ups, all of that stuff. But we will always, for every project, use some kind of version control, have a CI and CD pipeline, and these days use Docker and Kubernetes. We've recently gotten access to a Docker server inside the school, and that's been fantastic. We've just been abusing that poor server. So, I've told you, what do you have to do to become a researcher? Well, there is a complicated and strange career path. So, first thing that you have to do, and many of you are already doing this, is obtain a bachelor's degree, BSc, your Bachelor of Science in Computing. But it doesn't have to be a Bachelor of Science in Computing. It could be a bachelor's degree for anything, really. Optionally, you can go and do a master's degree, further your expertise. Then you will go and do a PhD. After you've finished your PhD, you will go and work as a postdoctoral researcher on a project. We'll talk about what exactly a postdoctoral researcher is in a minute or two. But here, this is where the path splits off, right? Where you can either go and become an assistant professor and do teaching, or you can focus solely on research forever. And essentially then, if you wanted to just do research at this point, you would go and become a research fellow. Or if you want to do research and teach, you would become an assistant professor. The next step for a research fellow then is to become a senior research fellow. The next step for an assistant professor is to become an associate professor, or used to be called a senior lecturer. But then both of you would end up eventually as becoming a professor. Now, what I'd say these days is you will find the pathway from the research fellow to the senior research fellow to the professor generally doesn't happen these days. And the reason why is that when a university is hiring staff, they're looking at you, and if you're coming in as a senior research fellow, they're saying, why would I hire you to just do research when I can hire an assistant or associate professor who will do research for me and teach classes for me? So the path on the right is it's few and far between. If you want to go that way, you have to be the top of your game, publishing in Nature all the time, winning Nobel Prizes and the Turing Award. You have to be the best, discover like Stephen Hawking levels research. So for most people, it's the teaching route. And then for some of us, we actually just quite enjoy the teaching and we don't see it as a necessary evil. Some people do, but I don't. So first step then, you want to be a PhD student. What do you have to do? Well, a PhD lasts in and around 3 to 5 years. Generally a paid scholarship. You get between 16,000 and 19,000 tax-free a year. So it's tax-free. So if you think about it then, that would be the same as being salaried for about 33,000 a year. So it's all right. It's okay. You get about 1,500, 1,600 a month to live on. Mainly just you and your PhD supervisor. And your PhD supervisor will be, an assistant professor or associate professor or a full professor. These days you actually have like a team of supervisors. And they help you direct and formulate your research. They might tell you like, oh, well, there's a really cool conference coming up. It'd be great if we had something to show there, or they'll challenge your assumptions. They'll generally guide you through the path. Now, what kind of supervisor they are, there's about 5 or 6 different classifications of supervisors. Some of them just want you to learn. Some of them are very output driven, where it's just about writing papers, showing code. Some of them want to put you in front of, something like Silicon Republic and get you talking and make you do all these presentations. Different supervisors have different ways of supervising. There's no right answer. It's a combination between the student and the supervisor, really. But what is a PhD? If I was to be very facetious, I'd say it's like a really, really long fourth-year project, but it ends with the most stressful exam in your life. That's the way I would say the PhD process is. It's a few years of kind of working on a project and then a lot of stress. Like, what's the PhD process if we look at these years? Year one, you basically would spend all your time getting up to speed. You are just reading. This is the first time you've ever really been introduced to research papers and conferences and a general field. Your job is to get up to speed on what everybody since computers were invented up to now have been doing, and you will pick a broad research area, right? So this is where you start to dig deeper into something. So you might know you want to work in image classification, but that's not the full story. Maybe it's you want to work inside how to optimize image classifiers. You're still working in image classification, but we're one level deeper now. You'll read a lot of papers on these. In year two, then, you'll begin to formulate your own idea. It's probably a combination of you've read existing papers and you say, hey, if we mix this person's approach with this person's approach, we can do something cool. Or you might draw on things from different sciences. But anyway, you'll have your own idea of what you want to do, your own idea of what my contribution to research will be. And you'll start work on that, and you'll write your first paper. And then at this point as well, you'll do a transfer report. This is kind of like a get out of jail free card in the PhD program, where after the second year, you can, if you want, leave with a master's because you've done enough to do a master's by research at that point. Or you would do the transfer report, which is like a mini viva, and you'll continue on for the final 2 years. In year three, what usually happens is your transfer report is the idea of your research plan. So it's the final 2 years of your PhD. What are you going to do? What will your contributions be? What papers will you write? Yada, yada, yada. Generally what happens is in year three, you have passed your transfer, you immediately throw it in the bin and do something completely different. But on paper, you should be continuously improving your idea and writing more papers. And it's generally in year three, that's when you would get most of your papers out, because that's when your idea is formulated, your system has been designed, and now you're just running experiments and writing papers. And then in year four, you're probably finishing adding one or two more features to your idea, and you're writing up your thesis. What is your thesis, and what is the examination? You write your thesis. It's around 120 pages, could get up to maybe 300. The real answer is how long is a piece of string, how much do you need to say? What happens when you finished writing your thesis? It is then sent to two examiners. It is sent to someone from your college who works kind of in your field, and then it's sent to someone who has been noted as an internationally recognized expert in your field. Both of these people read your thesis, and then they will meet you in a room for your Q&A Viva session. You'll give them a bit of a presentation, and then it's just they are sitting there with your thesis in front of them, and they've marked off pages, and they're just going through it saying, on page 5 you meant this, did you mean that? And some exams can last, I think the shortest one I've known was about an hour, maybe 40 minutes. The longest one I've ever seen was about 8 hours. Mine was about 1 hour and 20 minutes. But they can be incredibly long. And now here's the stressful part, right? When they finished asking all those questions, they'll ask you to leave the room. And you'll be waiting outside for about 10 minutes. And then there are only two things that can happen. They'll open the door and they'll call you back in and say, go back and do more research. Or they'll open the door, call you back in, and say, congratulations, doctor. And that's kind of our tradition. You bring them back in, you say, congratulations, doctor, and then they say, thank you, doctor, and then the next person comes along and says, congratulations, doctor, and it's doctor, 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 doctor. But that's things. So if someone passes their PhD, if you were ever if you were ever examining someone for revival, that's what you do. You bring them back in, you say, "Congratulations, doctor." It has to be the first words you say to them, because we're all about traditions. Oh, you've got your PhD. You are now a newly minted doctor. What do you do? Next step is to become a postdoctor, postdoctoral research. This is where you're employed on a funded research project, right? So you've got a general task to do. So when I was in Vista Milk, we had a task to do. It was basically figure out some way of integrating a lot of agricultural data systems together. So some things might be sensors from cows, other stuff might be data from the Department of Agriculture. My task was come up with a system, put them together. Your boss in this case is what's called your principal investigator. This would be the person who actually got the funding. And they can either be a senior research fellow or someone who's higher than, or an assistant professor or higher. So with a postdoc then, the work is a bit more defined and structured. You can actually find yourself at this stage of the process turning into more of a manager, where you might end up managing research assistants, so summer interns essentially, or PhD students who are somewhat involved in the process. So you could end up being a manager at the stage of being a postdoc, in addition to doing your own work. And your main output for the postdoc is papers. Never stop writing papers. We have this saying in academia, unfortunately, it's called publish or perish. It very much is that: keep writing papers, never stop writing papers. Your first paper is a nightmare and it'll take you 6 months. By the time you're a few years in, you can get a paper out in a weekend, and sometimes even a day. You just get used to the process. The optional steps then for being a fellow and a senior fellow. So once you're a postdoc, you can actually then at that stage go and do self-directed research and get a funded fellowship. This is now where you become a fellow or a senior fellow. And the idea here is that you get funding to pay yourself, right? So a principal investigator would get funding to pay for a project and employ staff, whereas a research fellow would get funding to pay basically their salary to do research. They might even get a bit more to have their own staff, but it's mainly to pay your own salary to do research. TLDR of that is a research fellow or a senior research fellow is generally their own boss. Can't really tell them what to do. Their funding isn't even really by a college. It's given to them as a person. So they're kind of mavericks. Alternatively, what I am is an assistant professor. So that is where I'm doing teaching and research. General idea is if the postdoc manages one team, an assistant professor manages many teams. At the moment, I have about 4 teams, about 15 people in total that I'm managing. That's not including student projects or master's projects or anything, just people who are employed on projects I'm working on. Your output is very much papers, funding, and public engagement. So, which is what this kind of counts as for me. This is a metric where I can turn around and say, I've done my public engagement for the year, thank you. So what's a day in the life for an assistant professor, or any professor really? Time management is the big thing. You have many meetings, never-ending Zoom meetings, especially now working from home, where little things like that would have been like a hallway chat or just popping your head into someone else's office to ask them a 5-minute question is now a meeting that takes an hour. You divide your time between 3 broad things: teaching, research, and admin. Teaching, this is your preparing for lectures and labs, making sure my slides are good, making notes, putting things on loop. All of that stuff takes time. Giving the lectures, you have to show up and talk at some point, which takes time. Answering student queries is something as well that can take time, depending on how obtuse a lecturer you are. I'm going by the amount of queries I get, I'm quite obtuse. And grading, which is only happens twice a year, but is an absolute pain because there's so many students, and like it really does take about 2 weeks in and around where you just have to block it off and say, I can't do anything for these 2 weeks but grade. So it's just something you have to take account of. Research. You're writing your papers, you're managing some projects, you're probably developing your own passion projects. And then admin. Well, you have staff that have to get paid. You have budgets to go over. Your staff needs computers. You need to buy cloud resources. Someone has to buy those and pay for them and approve this stuff. From the teaching admin side, students have to be registered for the modules you're teaching. Your exams have to be uploaded. There is a lot of hidden admin and committees and boards. The bowels of a university, when you get into the teaching space, research fellows and senior fellows have no knowledge of this space. The teaching brings on a whole host of committees and boards and deadlines of things that have to be done. Anyway, I've been talking about a lot now about papers. What is a paper when we say papers? What is it? They're our currency, right? If you want me to do work, there has to be a paper in it. If there's no paper, there's no work done. It's a waste of my time because I could be doing work that could result in a paper. There are two kinds of papers that we have in computers. We have journal papers and conference papers. The idea is journal papers are large, maybe 20 plus pages. I've seen some that go to 60. They describe entire systems. They describe in-depth experiments, right? So generally the idea is for a PhD student is that when throughout their course of their program, they're writing papers about every little thing they do, conference papers. But then at the end, they'll bundle their entire thesis up and publish it as a journal paper because it's the entire system. It's the entire process. Then you also have conference papers, which are smaller, 5 to 15 pages, describes an aspect of a system, maybe a small algorithm, something like that. But the nice thing about conferences is you would travel to conferences. So you would get paid travel expenses to go to conferences. You get paid expenses to go to conferences. That was a very nice draw, is just being able to travel. Free, you go to very nice places. I know people have gone, I mean, personally, I've been to France, Greece, loads of European countries all paid for. I think the furthest afield I've ever seen anyone go was a conference in Hawaii. Unfortunately, it wasn't in my field, but you know, you could get lucky. We always write our papers in LaTeX or LaTeX. Always, always, always. Never Word. You will be laughed out of the computing building if you write a paper on Word. So, I also talk a lot about funding. Why do we have to get funding? I get a salary paid for by the state. Why do I need funding? In general, more impactful research, bigger projects are more expensive, right? You need to get money to run GPUs in the cloud. You need maybe a lot of computers. Maybe you need to buy a lot of sensors. They all have to be paid for somehow. You may need a team of people to work on a project. So their salaries have to be paid for from a funding call. So essentially what happens is a funding agency will put out a call. So you might see something where it says in the news, like 2 million has been dedicated to research in the sustainable economy. So that's actually a funding call then, where you'd write an application. The size of the funding application that you write is roughly equivalent to the amount of money. Right? So example for me is one was BNS if I Discover grant, which is about 10,000. Takes me a week to write. It wasn't a week full time, I thought in around. If I was to put it all together, I'd say probably a day or two dedicated to get that. Different one was a H2020 application that we wrote, where we were asking for about 5 million from the European Union. That took more than 6 months to write, and we had about 15 or 16 international partners. In fact, it was so much money, we actually had staff hired to write the application. So you could actually hire staff whose job it is just to write funding applications. So when I talk about funding, people think it's this, but it's actually more this, because this is an important thing that people don't seem to get. I don't get to pay myself from the funding I get. If I get 5 million euro in funding, nowhere in there does it touch my salary. That is just money I have to spend on other people's salaries. What I do get at the end, though, is a portion of that money at the end of the project to use as, I don't want to say the term slush fund or expense accounts because it sounds like the 1980s, but you get that money to pay for interns or do whatever you want with afterwards. So you get some money to try out ideas for free. So why should you become a researcher? Well, you get the ability to do impactful work. And mainly because the work is not profit driven, you get to kind of focus on things that industries generally wouldn't look at. You get to stay up to date with the latest technologies. You always get to play around with new things and try out new ideas. And you have the freedom to define your own path. So how would you get started? Well, it would be a good point to start would have a very general idea of what interests you. And I mean very broad strokes. Like, I like the idea of data analytics. I think natural language processing is cool. Something like that. Just a very broad idea of what you'd like to do. And then talk to the people in DCU or in any respective college who are more than happy to help people through this process. We're more than happy to give people advice and guide us, because essentially what you're doing there is you're shopping for potential supervisors. And as a rule of thumb, your supervisor should work in the same space as you, because someone who works in your field will definitely be able to help you more than someone who doesn't. And then the first concrete step is actually to get onto a PhD program. So some examples of these are the SFI Center for Research Training in Artificial Intelligence, or ML Labs, Machine Learning Labs, which is run out of UCD but is in DCU. These are kind of the newer PhD programs, where one criticism of the original PhD program was it's quite isolating. And they're right, it very much is isolating. It's just you and your supervisor, and you're just there kind of by yourself for 4 years. These ones now, the idea is you actually spend a fair amount of time with a PhD group. You will travel from different colleges. You might spend a week in DCU, and then a week in UCD, and then a week in UCC, in Cork. And all the time you're being presented about different ideas and different research from researchers. So I would have to, so last year I went and gave a presentation I think it was the AI CRT, but I gave them a presentation just on here's data warehousing as a field if it interests you. The more classical route would be something like an Irish Research Council postgraduate grant or something like that, where the difference would be that if you're in a CRT or in a research center funded by a research center, you'd have some admin overheads. There might be a student conference they want you to write a paper for. You might have to get up and give a presentation on something. Whereas IRC students are generally, I say generally, a bit more maverick. They can kind of do their own thing because the funding is just for them. They're not part of a wider consortium of funding. But anyway, if you want to get a PhD, any of them will work. They'll all turn into PhDs at the end. Personally, I think the CRTs would be a better approach these days, because you get to learn things, you get to meet more people and try out new ideas a lot earlier on in the process. But anyway, so that is essentially a very quick overview of being a researcher and what research is, and how eventually, no matter what job it is, you will always turn into a manager at some point in your life. So, thank you so much. Does anyone have any questions?
Have you got the chat open, Michael, or do you want me to
Zoom
read
chat?
questions?
No,
there's no Zoom chat. It's the Twitch chat.
Oh, no, I do not have the chat
Okay.
open.
So if anyone has any questions, put them through in the Twitch chat, and I'll.
I can read out the questions if you want.
Yeah, no, I've got them up on my phone.
All right. So when you did computer applications, what did you do for your third year project and fourth year project?
My third year and fourth year project. Wow. So my third year and fourth year projects were my fourth year project built on my third year project. So I'm getting a bit iffy on what did I do in what year, because I can't remember now. But the idea was I hooked into the ODB interface of a car, the ODB2 interface, and started grabbing up all the information about my car. And I'm remembering, right? The third year project was an anti-theft system, right? It was literally just have a Bluetooth sensor in a Raspberry, not even a Raspberry Pi, an Arduino in a car with a GPS sensor that could detect if the car was moving and your phone was in any kind of area. If it wasn't, there was a GSM sensor on the Raspberry Pi that would send you a text message saying, hey, your car is moving, and a link to Google Maps to show you your car moving. Then for the fourth year project, we added on to it by hooking into the ODB of the car, grabbing out stats, showing graphs of like, you know, petrol usage. I know cars have it these days, but they didn't when I did my degree. So graphs of like, you know, your miles per gallon, air pressure sensing, reading all of that stuff in as well. So that was I still have the actual the Raspberry Pi and Arduinos somewhere, but that was essentially my project. My supervisors were, so you wouldn't remember, I don't think he was here when you guys were, but it was Professor Joe Marks. He was a top guy. He was one of, you know, Dijkstra's algorithms. You've heard Dijkstra. Yeah. My third year students will have heard Dijkstra's algorithms anyway. But he was a PhD student at Dijkstra. He was a top guy. He's retired now. But he was one of my supervisors, and Stephen Blott was the other supervisor. And then I think Stephen Blott was Joe Morris was definitely my fourth year supervisor. I can't remember if Stephen Blott was my fourth year supervisor now as well. But anyway, yes, that's what I did for my projects.
Okay. Another question is, would you say that finding an idea for researching is hard?
Well, people fear the most this idea of like having to come up with an original idea. But the fact of the matter is, it's like like when you say that, people think of like, oh, it has to be lightning in a bottle, it has to be world changing. But the fact of the matter is, you don't know if something's going to be impactful. You only know it's impactful after you've published your paper and you turn around and see that, oh, this is getting a lot of citations very quickly. So coming up with an original idea, usually at the start of your PhD, your supervisor will have some hand in that. They'll have read the papers and saying, hey, no one's doing some work in X, Y, or Z. You should maybe look into that. Hint, hint, wink, wink. And then it's up to you to kind of decide, well, what exactly am I doing in this space? In terms of an original idea, like, we have a very broad idea about what's an original idea. Like, your idea could be combine two other people's approaches together, or your idea could be like throw it all out. I have a whole different idea for an algorithm they're gonna put together. People worry too much about the impactfulness of their idea when they don't know what they can't say if something's going to be impactful. It's like saying, how do you know a video is going to go viral? You don't. It's kind of about how it's received. So yeah, I guess what I'd say is the PhD students, yeah, they worry about if an idea is going to be impactful, but I honestly, over time, you get a pretty good idea about what's an idea, what's not an idea. You'll be able to read a few papers and say like, oh, no one's done this or no one's done that, and then go do that. So.
Wow.
I can take this one.
Yeah, go for it.
Mm-hmm. You said that researchers get to decide their paths, etc. In terms of weekly hours, do you feel that you have had some time / leniency with the amount of time you put in, or is there a very consistent weekly input? Basically, how much control do you have over your schedule?
It depends. Am I teaching this semester or not? Is really the answer to that. So I'm teaching this semester. So I don't have a lot of control because it's about the classes and they can take priority. It depends on the week, honest to God, as well. Like, if it's grading week, then your research kind of just drops off for that week. You're grading that week. We work over the summer, though. So we're not teachers in that regard. Like, when you're all gone on your summer break, I still show up at 9 in my office, and that's where we'll get bulk research done, is there where there's no teaching. People are on holidays. Some of the smart people now will actually swing. They'll spend one semester teaching and another semester off just doing research. You have to have a fair amount of political power to wrangle that from your boss. So yeah, how much time do you have? It really is week by week. It's week by week. You'll know. Generally now, this semester I have about, I want to say 3 days for teaching things and 2 full days for research. But it changes on semester. It's down to what your timetable is as well. So you don't know, you kind of blend it around. It changes every 12 weeks, like the semester changes. So.
Cool. That's a good answer. Aside from the standard good grades, what can someone do at an undergraduate to prepare / help them to get into competitive masters / PhD programs?
Like, so that's the. So I guess you didn't ask, but I'll say this part first is, if you know you want to do a PhD, I wouldn't do a master's first. I mean, I would apply straight to the PhD program. Because ultimately, if you think in terms of qualifications, you'd come out of it saying, I have a master's and a PhD, and it's like, oh, well, you have a PhD, so no one cares if you have a master's. So if you know you want to do a PhD, then just go straight and apply for the PhD program. If you're trying to get an idea of it, then go for the master's. The difference these days between the master's and the PhD is a master is almost like another year of your degree program. So imagine instead of going through 4th year, you actually ended up in 5th year. And the classes were a bit harder. And there was another 5th year project now, which is a bit bigger in scope, and you did it over the summer. But that's kind of what the master's is. In terms of the good grades and stuff like that, apart from, it really is the good grades for the most part and having an idea of what you'd like to work in. That's pretty much it. Now, when I say good grades, you don't have to be the top of your class. But as a general rule of thumb, about 2-1 degree or higher. So, I'm trying to think now, what's that, about 65% average or higher? Something like that in and around is what you should be going for. You find, like, generally people get like the top grades. That doesn't mean that they'll be good at a PhD, because the thing about PhD is it's not even about how smart you are. It's about how you can stick to self-directed work, and the difference is even more stark if you compare it to, like, imagine like a Leaving Cert student, where essentially the way to pass the Leaving Cert and get good grades is read off this book and write this book into the exam book and write this book in the exam. Whereas in the PhD programs, you're focused a lot more on your dedication to the work and your quality of the work, not so much your ability to recall anything. But unfortunately, there are still those minimum requirements when you're applying. So it really is just the grades and having an idea of what you want to work on. If you wanted to get started, really, you essentially just go to Google Scholar and type in. I mean, it's how you start when you do your first year in the PhD program. You go to Google Scholar, you type in an idea, and you just start reading papers. Oh, so I'll add one more thing though. A broader way to get an idea of the field though as well would be to look at things like the MIT Technology Review and stuff like that. So read those. They're kind of almost like, think of it like newspapers about research. So if you read them as well, they can give you ideas about what people are working on and what you'd be interested in. But knowing what you're interested in or what you want to work in is probably the biggest thing, I'd say. Okay.
Cool. Why did becoming a researcher appeal to you more than going into the industry as a full-time employee of some company?
Like I really do mean when I say freedom, and I guess what I mean is, so when I was working as a consultant, it was in a company, and the money was great. We were charging fantastic stuff, but it was essentially just always build an internet system in Java or build an internet system in C#, right? And I knew going further down the line that even if it's not Java and even if it's not C#, the nature of this work is always going to be some form of internet system or some form of portal. And unfortunately for companies, that's kind of it. It makes sense. A company does one thing to make money. So if you wanted to have the freedom to work on your own things, you either have to work on passion projects outside of your company or move jobs very frequently. Problem with the working on things outside of the company is it's fine now. You're all childless and you don't have you're not working mad hours like in the consultancy. I think the the latest I left the office was about 2 a.m. or something like that. So the idea of like, oh, well, I'll just do them as side projects on the side. As you get older, it will get harder to keep that up. When, you know, if you end up having kids or something like that, that's the big killer. And say goodbye to all your side projects now. You have a child, that is what's going to take up all of your time. So going forward then is like my thing is I always wanted to, I got bored very easily working on the same project. I got bored when I was satisfied that the problem was solved. Sometimes it would be before I even actually started developing. If I just wrote it down on paper and said, yeah, that algorithm checks out, then I'd get bored and I wouldn't even bother implementing it. But I knew over time that that job wouldn't make me happy. And, you know, it sounds so like first world country idealist, kind of do what you love kind of thing. But essentially that's it. Now I do have friends who moved into industry. And some of them do make quite a bit of money. But another reason that academia is nice is that they're making a lot of money, but they're on contract work, right? So they have a set amount of time and their contracts are coming up and they're wondering where the next job's going to come from. Whereas I consistently, now until forever, will have that salary coming in. And when you're getting older and you're looking for things like a mortgage application or you're thinking about children and the rest of your life, having a guaranteed amount of money coming in every single month, forever, regardless of what happens to the global economy or what happens to anything else, is quite nice as well. So you get freedom, you get a bit of a safety net. You don't have to leave. You don't actually have to leave startups though. As I said, I'm working on a startup project. It is not uncommon for like an assistant professor to get some Enterprise Ireland funding, start on a startup, be a assistant professor here and the CEO of that company while it's starting up, maybe take sabbatical for a year from the job, get the company off the ground, and get a whole lot of shares. There are quite a few professors I know who are multimillionaires from doing that approach. So money it's not impossible to become very, very rich in academia. If that is what you want to do, you can spin off startups, and it's safer to do it in academia because if the startup fails, I still have my government salary. I still have that nice money coming in. So you get a bit of best of both worlds there, I'd say.
Where did that question go? When you were in your undergrad career, did you decide to do a PhD, or was it after you graduated?
It was always in the back of my mind. Right, I guess that's the thing. It was always in the back of my mind. But I kind of thought like, oh, you know, I'd make a fair amount of money. I'd go out into the industry, get some experience. I always felt like I'd go back and do one. I just didn't think I'd do it so soon. I didn't think I'd get bored so fast and do it so soon, if that makes sense. But I always knew I was going to do one. Eventually, I knew I'd get one. Now, in my head, I thought it would be something like when I was about 50 or 60, I'd go back to college and go do one, which some people do. We have some PhD students who will be quite elderly, so it's not uncommon to do that. I just didn't think I'd get bored so fast and move off. Now, for me though as well, part of it was the timing. So a new research center just launched. They were opening with nice stipends, the application process. The timing was right based on that, because after that, before the CRTs opened, there was a bit of a lull. There wasn't a lot of money to pay for PhD students. There wasn't a lot of stipends going on. So, you know, we don't have a lot of PhD students now in the school because of this lull that they had. But now it's building back up again. So it kind of comes in waves, the funding. So pick the right moment and go, I guess. Okay.
Yeah, I guess another one. Would you ever see yourself going out into the industry?
Probably only an sabbatical or something like that. Like only as a sabbatical, I guess is what I'd say. I'm happy kind of here working with industry within the research projects, but I don't know if I'd work in industry full time again. I mean, the option's always there, and that's the nice thing as well about having a PhD. I looked it up when I got my PhD. Like the starting salary, generally the idea is the starting salary for someone with a bachelor's in computing is, I want to say, maybe between 30 and 40,000, something like that. Starting salary for someone with a PhD in computers, depending on the field, I work in data warehousing, which is a very sought after one. So my starting salary would be about 80 to 100,000, something like that in that range. So it depends, but no, I don't think I would. I mean, the nice thing about this job is it honestly doesn't feel like work when I wake up in the morning. And it definitely felt like work when I wake up at 7 and get the bus into town, and it just doesn't feel like work to me. So that's I don't think I'd work full time in industry again.
That's a good way to put it. I don't know if there's any more other non-meme questions, to be honest.
No, I've just logged into the thing now. I can see think of all the Fortnite skins. Just a couple of photos.
Ask my question. Can I research anything I want, like peanut butter sticks?
Can I research how Animal Crossing stuff? Yeah, you can research whatever you want. It mightn't get cited or published. There's no one stopping you from researching it. There are people who do. I love the off the wall research though. Like one of my favorite papers. What was it? It was something like, and they did it because they knew people would read it. It was something on gamification and AI. But in order to, I guess, make it eye-catching, was they actually tried to use Super Smash Brothers to see if they could train like a bot to beat people, like a neural network powered bot to do that. Yeah, so it's the toggle. I'm going to research Among Us has altered the youth's brains. Everything is sus. What's your main in Smash? Well, I can answer that one actually. So my main is Fox because I played Melee. I actually played Smash 64 on the Nintendo 64. You guys alive when that came out? Oh, maybe not. So anyway, I played that, and Fox has been my main ever since. What would your comments be on becoming a contractor against becoming a researcher? Well, so a contractor, you make a lot of money, you don't have a lot of security, and you would tend to get as a contractor very boxed in. That you are the person to do X, and that is your job, and that is it. So you are the person to build internet systems. You are the person to call if we need to migrate databases, something like that. It's very boxed in. It's very specialized work. You'll get paid a lot of money, but if you're happy doing the exact same thing over and over again, then contracting is the way I'd see it. Is it common at all for researchers to focus on discrediting others' papers, journals? No, you'd be afraid that they'd do it to you. No. You don't do that. No. If you had the chance to do a PhD again, would you stay in the same area? I would. Now, it's not uncommon for people to do their PhD in one field, especially in computers, and then completely change it. Ask some of the older lecturers, what did they do their PhD in? They did their PhD in things that don't exist anymore. So even after the PhD, it can completely change. Like I expect in 20 years, whatever data warehousing was when I studied it is completely different now. Or it might even exist. Maybe there's a new kind of database that does it all for us. So you will change. Adams Fox only Final Destination. Yeah, fight me. Do you enjoy the teaching aspects? I do enjoy the teaching aspects. I will leave out this question because it's come up before, but I enjoy the teaching. But I kind of come from a family of educators. My mom's a teacher, my dad was did some lecturing in UL and stuff like that. No, very little public speaking experience. The ability to give presentations, any fear of public speaking is beaten out of you just through the sheer amount of presentations you have to give. Eventually what happens is you don't become nervous, you just be like, another presentation, and you just get up and talk. Even without the teaching in research itself, there's a lot of presentations. I'd actually say it's more nerve-wracking giving a presentation at a conference than it is teaching. where at a conference you're presenting your paper and there are other people there who are going to ask you questions on your paper, and yeah, some of them could be real show-offy idiots kind of sometimes. But where does all the time spent researching leave in relation to other passions outside computing, or maybe tangentially related? Yeah, it's good time management again, is what it says. So I don't very much do much during the week. I very much kind of work, research, then maybe a walk, maybe some exercise, and then bed. It's setting yourself time off, essentially, is the thing. So I'm trying these days more and more to be like, I am not doing anything over the weekend. Used to look at student emails and stuff like that and answer things. I'm like, no, that's not healthy. So where's the time spent? You have to, since it's so self-directed, you actually have to be hard on yourself to take time off as well, or you will burn out fast. You have to be kind to yourself and say, this is time I'm taking off. Are you capable of making an indie game? I mean, yeah. Problem with game development, though, is that it's not even like the game logic that's a difficulty. It's in making the assets, and I am not an artist. So much of game development is more about getting assets on screen and doing that stuff, because the game logic itself isn't particularly difficult. It's about managing assets. So yeah, I've made platformers, I've made RTSs that will never see the light of day, mainly because what I made them in I don't think exists anymore. But now you can make games. You can make games. Do you have a favorite project? Yeah, okay, we'll finish on this one. That's the start. Finish on the favorite project and the starter project. They're the exact same thing, I'm going to say. The starter project is financial accounting, right? So the idea would be that someone applies for a loan, we scoop up your accounts, do machine learning analysis on them, compare them to other people, and come back with an idea of how are your accounts in general. So let's say you're like a furniture store in Cavan or something, you're asking for 10,000. We'd look and say, well, all the other furniture stores don't ask for that much money generally. They pay back the loans better. They have less creditors. A lot of machine learning and ML on financial accounts. A lot of money out of it. Favorite JoJo episode? I said I would say that at the end of the semester. It is not the end of the semester. So that is not happening. Not yet. Anyway, guys, thank you so much.
Thank you for coming along. It was great.
Thank you so much for speaking.
No worries. I hope the presentation was interesting. That promises. Of course, if any of you do have any questions, feel free to email me. I'd be more than happy to help you. But aside from that, anyway, thank you so much for having me, guys.
Thank you.
Okay.